Hello everyone. In this tutorial series, I'm going to focus on electronic design automation and I'm going to use the software package called OrCAD. So OrCAD is a software suite. It comes with a lot of tools. So first of all, let's take a look at the idea of electronic design automation. Now let's assume that you come up with a great idea and then finally you need to bring down some kind of a nice uh, circuit diagram, the component mounted in a printed circuit board, something a finished product like this. So it's not one simple step. Directly, you come up with the idea and then you produce the final version. So there are a lot of stages involved in order to get the final version. So in general, if you are working on electronics, you start with a drawing schematic diagram. So schematic diagram is the diagram that you draw with circuit symbols like diodes, resistors, and some gates over here. And so in order to do schematic diagrams, you need to look for the system requirements, the inputs and output, how things should be processed, and the power requirement, and things like that. Then, with your experience and knowledge, you draw this circuit and come up with, okay, this could be the better schematic diagram. So once you have the schematic diagram, one option is you can do the prototyping, either using this kind of prototyping board with the solder, or you can use solderless board like breadboard. You do the prototype with different wires and see whether you are getting desired output. However, this option is kind of outdated, I would say. So when you want to do this from schematic diagram to prototype, of course, you need to have physical components and then you connect it. And if something is missing, most probably you may have to order it again or purchase them again and do it. And while doing this work, if you do something wrong, for example, if you put your capacitor in wrong polarity, it might blow up. So in that case, again, you need to buy component and do it. So it is kind of expensive thing to do the prototype directly, provided that your uh, schematic is not perfect at this moment. So this is where one thing coming in handy. If you could do the simulation using really nice software, there is a mathematical uh, model library called PSpice. So it's a PSpice is called engine, where you have a lot of mathematical models you can plug into different electronic component, and engine will do the simulation and return the output. So here we also use Spice engine, and it's called Spice. The ported to PC we call PSpice. So we are going to use PSpice engine to do that. And when you do the simulation, it's all on software. You can see whether you can change your input as you wish. You don't need to have very expensive power supplies or anything, signal generators or anything you don't need. You just do the simulation by providing different inputs and you see whether you are getting desired output. If you are getting desired output, if you are not getting, again you go back, do certain changes to the schematic diagram, come back, do the simulation, again you go back and come back to simulation, and you can keep on doing this one until you get the satisfactory level outputs. So once you have the output, next thing is that you need to have a PCB artwork design. Usually, when you have simulation output, what we do is we do a kind of prototype and see whether it is working. Because although you get output from simulation, there will be practical issues when you do the uh, prototyping. And in certain cases, if your circuit design is very complex, it's nice that if you could directly convert that into a PCB artwork like what you see over here, and then you can solder it and do the prototype, especially on the PCB. So when you do the PCB artwork design, there are a few things you need to take care of. apart from connecting all the components as you wish, you need to do the mechanical calculation. So you need to consider how big your capacitor is. You need to physically allocate that space. And for the resistors, and you can't overlap them. So you need to have some isolation. And also you need to think of thermal isolation. So if there's like a heavy power dissipating device like voltage regulator, so you need to have space for adding heat sinks, and also it could be mounted close by the outer surface of the enclosure. And also another thing you need to consider is electromagnetic interference, especially when you have high speed switching lines. So internal electromagnetic interference could be very large. So in that case, in the design, of course, you can think of different mechanism to have kind of Faraday cage like structures so that you can isolate certain areas with ground. So those are the things that you need to do. So once you have the nice PCB artwork done, you can directly do the prototype. So that is how you kind of, when you have electronic design automation suite, you do the prototype and you convert your idea to design. So nice thing about this is that when you have the schematic diagram, you can do the simulation, and later on you can convert that into the PCB artwork, so that it's guaranteed that all your connections that you have in the simulations are in the PCB artwork design. And also with the software, you can easily force to get mechanical calculations done automatically, and thermal isolations, and up to a certain level electromagnetic interference issues. Uh, Again, of course, when you do the prototype, there may be issues. You might have to go back and change the schematic and do the whole thing again, right? So that is the nature of electronics, especially if you are doing uh, research and development. In this tutorial series, my main focus is to do three things. One is how to do the schematic capture, and then we will do different types of simulations. So simulations will play a major role in this tutorial series. So under the simulation, we will do bias point analysis. That is the very basic type of analysis you can do with the simulation. It is a static situation. You have some circuit, you supply some voltage, you measure the voltages, currents, and maybe power dissipation from different components and devices. Then we can do DC sweeps. So DC sweeps is a, you have one parameter, you change it from one value to another. For example, you might have a input voltage source. So the voltage we might change from 1 volt to 5 volt in 0.5 steps. So something like that. So it's a bias point analysis we do with different values for a certain parameter. So the parametric sweeps also comes under DC sweep. So parametric sweep is you can change a resistor value from one value to another value in certain steps, or capacitor value. So things like that you can do. Then we have time domain analysis. So time domain analysis, also we call transient analysis. It's when you start providing time, providing voltage to the system. Uh, uh, as soon as you supply or allow your circuit to run, then you look how the voltages or currents or power dissipations varies over the time. So that is what we call time domain analysis or transient analysis. So the idea of doing time domain signal analysis is that you do bias point analysis over the time and record the data. So in the DC sweep, it's a static case. You change certain parameters and do the measurements again and again. Time domain, you take the measurement in the static circuit, you take the measurement over the time. So it's a time series analysis. And then AC sweeps. AC sweeps are basically deal with frequency changes. So especially if you want to see the frequency response of a certain circuit, you can do AC sweep. So you change input frequency from one value to another value, maybe logarithmic scale, and see how your output varies. Then later on, we will move to PCB artwork design. So that is another totally different tool that we will use. So the software application that we are looking at over here is Cadence or OrCAD. There are a few reasons why uh, I would like to introduce you to OrCAD. One is they are like industry leading electronic design automation tool, and also uh, another one advantage is that you can always download student edition and learn this one. And when you go to industry, you can make use of that. So they are very kind, provide with the student edition so that you don't need to pay a lot of amount of money and get things done. And also the user interfaces are very user friendly in this tool. So basically we will use most probably a few tools out of all these tools available as of now. So with that, I will stop this presentation and see you with the next tutorial. So the way that I arrange tutorials is I will have very for each and every type of, for example, simulation, I will have basic type of simulation and I will take some example in advanced tutorial. So that is how I'm going to arrange those tutorials. So see you with next tutorial. Thank you very much for your time.